When we talked about rational numbers, we said that they are numbers that can be written as ratios of integers. Irrational numbers are numbers that are not rational, so they are numbers that can't be written as ratios of integers. We've seen that rational numbers are either integers or have decimals that either end or repeat. Irrational numbers, therefore, have infinitely long decimals that don't follow any sort of pattern. Perhaps the most common way that we run into irrational numbers is through taking square roots of numbers that are not perfect squares, just like we tried to do with the slide example. There are some other numbers that have special roles in math and physics that are also irrational, like the number e, which is about equal to 2.71828182845 ... or pi. Please remember that I've just rounded off these decimals because I don't want to write any more numbers. But like all the other irrational numbers, pi and e have infinitely many numbers in their decimals and they do not repeat. So now we've developed a whole world of numbers that fit most things that we need to count, measure, and calculate in everyday life. There are still more types of numbers that we haven't touched on yet. Let's look at the whole entire world of number just for a second. Let's start with the natural numbers, such as 3 and 718. We then went from the natural numbers to the whole numbers by adding 0 to that set, and on to the set of integers by adding the negative whole numbers. From the integers, we get to rational numbers by creating ratios of integers with a non-zero denominator. Those numbers which are not rational are known as irrational numbers, such as e and pi. They have infinitely long, non-repeating decimals. Finally, we get to real numbers, which include the rational and irrational numbers we have discussed this far.